Hello again everybody and welcome back. In this video we're going to perform a walkthrough on TensorFlow's object detection functionality, so let's go ahead and get right into it. So I'm going to link this in the description below, but just in case you'd like to know how to get there without the link, if we type git hub GitHub microcontrollers and more, and then we go to here, and then we go to repositories, and then we're going to go into this here, TensorFlow Tut3 object detection walkthrough. And then we're going to go ahead and clone that, and you can clone to wherever you'd like. I'm going to clone to documents, so we have to jump in here and get that directory extension here. So we're going to go cd to whichever directory you'd like to clone to, and then git clone, and then we're going to go to clone or download and copy that, and there we go. So there's our two commands. So then we'll go ahead and bring up a command prompt, and then we're going to go ahead and do that, and there's a second command, and this is a pretty small repository, so it won't take too long at all to clone. And it's almost done. There we go, all set. So now we're going to go into documents, and there we are, TensorFlow Tut3 object detection walkthrough. And so we've got this Word document and PDF document, so you can view the PDF document if you don't have Microsoft Word, but I'll go ahead and open the Word document. And then so we're going to dive right into it here. So the first step is I'd really suggest to complete the previous two videos in this tutorial series. So I'm going to, when I'm done with the videos, I'm going to put a link to them here. And then here are those repositories as well. And so the second step is really, I would definitely suggest completing the first two tutorials before this one. You may encounter some error messages, or I might say some things that don't make sense. So please complete the previous two tutorials if you have not already. So continuing on, we're going to clone the repository containing this document. So actually we just did that, so now we can go on to number 4. So we're going to follow the TensorFlow Object Detection API README installation instructions. So if we go to, let's see, I'll show you how to get there rather than take a look at the link here. So if we do GitHub TensorFlow, and then that will take us to here. So then if we go to TensorFlow, so here's all the TensorFlow repositories. As you can see, there's quite a few. The two I seem to gravitate to over and over are TensorFlow and models. So if we go to models, this is what we're going to clone today, and it's actually a pretty decent sized clone. Takes a moment. My internet connection is not the fastest, so to save some time, I already cloned that to downloads, and it's right here, models. And I should also mention that what we're going to work with today mostly is in the research directory here. So if we go to research, and then we look for object detection, which is right here, this is mostly what we will be working with in this tutorial today. And in the models repository, if we go to the root of the models repository here, that is to say, we'll find some different directories here, one of which, of course, as we just took a look at, is this research directory. So from what I understand about how the TensorFlow models repository is structured, when something is still kind of under development to a degree, it's put here in the research directory, and then when it's ready to be sort of more officially released, it's removed from research and then put into this structure here. So we can anticipate that probably eventually object detection will be moved out to here, but for the moment it's in research. So that's something to keep in mind if you're watching this tutorial 6 months to a year from now. If that change is made and some other changes are made to this process as it's still under development, I'll probably re-record this video eventually, but I can't re-record the video every single time a minor change is made. I can update the walkthrough document, so that's something else to keep in mind, is if the walkthrough document and the video differ, you probably want to follow the document because that's generally speaking going to be more current. But in any case, continuing on here, so if we go to research and then object detection, and then if we go down to here, we will find these installation instructions. So these instructions are written with definitely an orientation towards Linux and Macintosh use. And I'm doing this video on Windows today, so there are some changes to what we're going to find here, and the walkthrough document reflects that. So let's go ahead and get right into it. So we're going to start with opening up an administrative command prompt. So definitely want to remember an administrative one. So you're going to right click on command prompt and then go to more, run as administrator. And I don't know if this shows on the recording, but it just asked me, do you want to allow this app to make changes to your device? Yes, of course we do. And then you're going to simply copy and paste these commands in here one by one. So In my case, this isn't going to do much because these should all be installed already, requirement already satisfied, and XML, requirement already satisfied, Jupyter, and that's going to have a whole lot of lines here, but they're all already satisfied, and should be the same with Matplotlib and pandas as well. And there we are. So we're all set there. So now we're going to clone the TensorFlow models repository. So we're going to create a directory /TensorFlow. And let's see here. So if we go to this PC and then C and then okay, so before I continue on, there's a few steps I have to do to get my computer, so it's probably the same as yours is at this point. So I'm going to delete that and delete that, and then I'm also going to go into system, and I'm going to undo a few path variable changes, and then I'll explain later on how to redo these changes. So if this doesn't make sense at the moment, that's just fine. So Python path, we're going to delete that, and then we will go into path and then edit, and then we will delete Python path and OK and OK and OK. And at this point, my computer should be configured pretty much the same as yours. So continuing on with the cheat sheet here. So if we copy TensorFlow here, so we're going to make a directory, and we're in the C drive, root of C here, so we're going to make a directory here, TensorFlow. So now we've got C:\TensorFlow, and then we're going to copy models into that location. So when that's done, then we're going to have C:\TensorFlow models. So then continuing on with the walkthrough document, the next step is we're going to download and compile protobuf. So we're going to follow this link here to Google's protobuf repository, and I'll show you quickly what that looks like here. So you're going to choose releases, and you're actually going to skip past the first few releases here, most recent few releases I should say, and we're going to go down to 3.4.0, and I'll explain the reasons for that in a little bit. So here we are, 3.4.0. And the only Windows download choice is this one right here. So whether you're using a 64 or 32-bit computer, you're going to choose Protoc 340win32.zip. And then actually I've already downloaded that to save some time today, so we can close out of here and close out of here. And that is, let's see, that's this download right here, Protoc 340win32.zip. So then we will go ahead and do extract all, and then extract. And that extracted to do a refresh, so it resorts it, that extracted to right there, and we're simply going to move that directory to the root of the C drive as well. So if we go here, move to C, and there we go. So before you continue, you're going to want to verify that you have those two directories. So you should have C:\TensorFlow models with this content in it, and you should also have C:\Protoc 340win32 with this content in it. So continuing on, the next step is to compile protobuf. So we're going to cd to C TensorFlow models research, and then we're going to run this command. But before we do that, let's take a quick look at the protos directory here. So if we open yet another file explorer, and then we go to here. So here is this directory, C TensorFlow models research object detection protos, and you see there's all these proto files, but there's no .py files yet. And the reason for that is because we haven't yet performed the compilation process, and that's one command line command to do that. So we'll go ahead and do that at this time. So we're going to copy this to a command prompt. Let's go ahead and close out of that, get a fresh command prompt here. So there we go, and now we're going to enter this command to perform the compilation. And if this works, which it just did there, you won't get any feedback here at all. I wish it had some kind of message here that said something like compilation successful, and unfortunately it doesn't have that. But if you go to the protos directory, you will now see that indeed there is a .py file that was not there previously for each proto file. So that tells us the compilation was successful, along with the fact that we did not get an error message here. And maybe I should explain this command a little bit further here. So let's bring up the command prompt. So first we're specifying here to run protoc.exe, and the reason that we're specifying the full path here is because we did not add C protoc 340win32 bin to the path. So the command line parser here would not know what we're referring to if we just put protoc.exe, so that's why we specify the full path. And then the second parameter here is object detection protos star.proto. So what this is doing is this is referring to all the files in this directory that end in .proto, and that's the reason I'm using protoc 340 is because something to do with the newer versions of protoc, I think the star character, they don't seem to be able to handle that correctly. I should probably file an issue about that on the protoc GitHub, but at least for the moment, hopefully that will be resolved eventually, but at least for the moment it's probably best to stick with protoc 340 because we know that will work. So we're all set on that step. So continuing on, we're going to test the TensorFlow object detection API using the pre-trained model within a Jupyter notebook. So if we cd to TensorFlow models research object detection, we're going to find a, let's see, we can close out of this now, and we can close out of this now. And so let's cd, well, let's, whoops, we don't want to do that. We'll take a quick view of this directory here. So if we go to C, TensorFlow models research object detection, you will find this object detection tutorial.ipynb. This, for those not familiar, this is a Jupyter notebook. So if we cd to that in a command prompt, and then we enter this command here, Jupyter notebook, that will bring up that file in the Jupyter notebook format here in the browser for us. And Jupyter notebooks are kind of popular at the moment. I still prefer traditional Python editor, especially PyCharm, makes writing Python programs very user-friendly here, but to follow along with Google's installation instructions, so we're going to run this here, object detection tutorial.ipynb, and then we're going to choose cell and then run all. And that jumps us down to the bottom here, and this has to download a model, so it will take a moment, but once you get to the actual point of doing the object detection, which is this loop here, it's actually pretty quick. So we need to wait just another moment for that. So while we're waiting for that, let's explain what the next step is. So the next step is we're going to run this script here, 0 verify models and protoc install.py, and that is going to be, let's see, so if we go back to documents and then TensorFlow object detection, TensorFlow tut3 object detection walkthrough, that's going to be this that we're going to load up. And at first we're going to see that there's going to be an error because we did not yet tell this script uses a library util, which is located at C TensorFlow models research object detection and then utils. That is, all this content in this directory right here is the utils library. And we have not yet added that to the Windows path. That was actually what I deleted at the beginning of this video or a little bit earlier on. So we're going to re-add that, and then you're going to see that that's going to resolve that error. And if this doesn't make sense at the moment, it will shortly. But let's go back to the Jupyter notebook. Okay, so this is all done running. So there are 2 dogs in an image being detected. And here's an image of people and some kites being flown at a beach, and those are being detected. So that worked. So we can go ahead and leave that, and we don't need that anymore. And we don't need that anymore, so let's go ahead and open this verify models and protoc install. So we're going to keep an eye out for those 2 import util lines, which are going to be a little bit of the way down into the script. And again, maybe I didn't mention this earlier, but this script is basically the Python notebook that we just took a look at. This is essentially just a regular Python program version of that. So if we go down to those 2 import statements, where are they? They're right here. And once PyCharm is done loading up, you can see it's got this progress bar at the bottom where it's still parsing some things. These should be underlined red eventually. We may have to run the script to get it to do that. And let's go ahead and run it. And there we go. So module not found error, no module named utils, and you'll notice these 2 lines with utils in them are underlined red. So here's how we're going to fix that. Is we're going to go to, let's see, we're going to go to System, Advanced System Settings, Environment Variables, System Variables. So if we go down here and type System, and then we go to Advanced System Settings, we don't need this window anymore, so now we can go to Environment Variables, and then this top section here is only for the current user, but we'd like to edit this bottom section here for all users. So then we're going to create a new environment variable. Let's see, so go to System, Advanced System Settings, Environment Variable System, add a new variable with the name Python path, and try not to grab an extra space there. So we're going to go down here to new variable name Python path, and then we're going to enter these 5 values, and if you only enter one of them like that and then you choose OK and then you go down here to Python path and edit, it still gives you this awkward view where you have to enter a semicolon and then the next one. But once you've entered 2 of them, separating with a semicolon of course, then now if you go to edit, it gives you this, Windows 10 at least gives you this nice window where you can copy and paste in line by line. So then we'll copy and paste this in, and then next one. And generally speaking, this seems to take the spaces off the end for you if you have one, but it's always a good idea to check. And then this here, and then we can paste that in, and that's good. Okay, so now we're going to choose OK, and now we're going to add Python path to path. So how we do that is we specify %Python path % onto path. So if we go to, let's see, up here just a little bit, path, edit, and then down here we enter path and then choose OK and then OK and then OK, and now we're going to bring up a command prompt. Let's bring up a fresh one, and then we're going to type the command set, and then we're going to check our variables here. So there's Python path just as we entered it, and the %Python path % should expand this content in Python path into path. So if we look here, TensorFlow models, models research slim, models research object detection. So sure enough, there we go. So our path variable is all set. So continuing on. Basically, the installation instructions that we took a look at earlier, we're actually almost done with those at this point. It has this mention here of add libraries to Python path and this export command. This is really if you're using Mac or Linux. What we just did is essentially the Windows equivalent of that. And then it has this next part here about testing the installation, running this model builder.test py file. You can go ahead and do that, but honestly, if you run 0 verify models and protoc install and it runs without error, then at that point we verified the installation. So go ahead and start a PyCharm and do that. And honestly, really running this model builder test isn't necessary. So we're going to open 0 verify models and protoc install, and then the progress bar at the bottom right is still loading up a little bit. And hopefully we will not get red underlines under these 2 utils lines. And we can go ahead and start that now and go ahead and run it, and we should see the same 2 scenes, so the 2 dogs and then the people and the kites at the beach. And give it just a moment. Okay, so there's the 2 dogs being detected, and there's the people and the kites at the beach. So our install is all set. And one thing that I should mention before we continue on is the next step is download images for training and testing. But just to give you a little background, the model that we've been working so far with so far is using this Microsoft Cocoa Common Objects in Context pre-trained data set, and they trained on, I believe it's tens of thousands of images in each of these 90 categories here, for these 90 objects I should say. And when I was looking for a relatively common object that I could find images on the internet for, it was actually pretty difficult to find one that wasn't already one of these 90. So eventually I decided to choose traffic lights in a traffic scene, even though that's already here. But if you follow the steps in the remainder of this tutorial, and to do that basically we're going to go through these 5 Python scripts, basically just one after the next. You can follow the same steps for anything, and that will work to train anything. You could train something more specifically that's in this set of 90, or you could train on any object you like. So we're not any further from the rest of this video. We are not leveraging the pre-done data set with the traffic lights already in there, but rather we're training on our own images at this point from here on. So continuing on with that, the first thing that we have to do is we have to get our images. So I downloaded a little bit more than 100 images of traffic lights in a traffic scene and saved those to my Google Drive and OneDrive file sharing services. So these 2 links here are identical. The only reason that I have 2 of them is just in case one ever goes missing. If I accidentally move something or it gets deleted somehow at some point, then the other will be available. So you can go ahead and download either of those, and of course I already did that ahead of time to save some time. So if we go to File Explorer, and then let's see here, Downloads, and that's going to be these here, trafficlights.zip or trafficlights.zip with the numbers. One of these is the Google Drive and one is the OneDrive one. I don't remember which is which, but it really doesn't matter. So we can simply do traffic lights, and then copy that to here, and then paste, and then that will unzip it. And then we can go into here, and here's our 127 images of traffic lights. So the next thing that we have to do is we have to use this program, or I should say get to use this program, because this program here, label image, is fantastic. And what this does is it's going to well, why don't I go ahead and start using it, and then maybe it'll kind of make sense as we go. So we're going to go to this label image GitHub, so you can follow this link right here to get to it. So thank you very much to this kind sir here. I don't know how to pronounce this person's name, but they wrote this program that's absolutely fantastic. So you're going to want to go to label image here, and then you're going to want to go to actually, I think it's better rather than to go to releases. There's some nice instructions here on how to use the program. Again, this is a very user-friendly program. It's pretty intuitive, but you're going to want to go to download pre-built binaries, Windows and Linux, and you're going to want to download the most recent version. I don't see any reason not to get the most recent one as of this writing. It's as of this video recording, I should say, it's 1.6.0. And I have a whole bunch of instructions here to kind of spell things out in a little bit more detail. You can refer to those if you like, but I'll just kind of walk you through it quickly in this video here. So I already downloaded that to, let's see, C, program files, and I believe it's, here we are, label image version 1.6.0. And then this is the content you're looking for, and you'll probably want to make a start menu shortcut or pin to your taskbar a shortcut to this label image. So then we can go ahead and fire that up. So in, just to refresh our memory here, in our downloads directory we have this directory traffic lights. So we have all these traffic scenes, but we don't yet have XML information notating where in each image the traffic lights are. So there's 2 traffic lights, there's 3, etc. So that's what this program label image is going to allow us to very easily do. So let's go ahead and start that up. And it takes just a moment to load. So we're going to choose open directory, and then we're going to go to let's see, downloads, and then traffic lights, and then we're going to select that folder or directory. And you'll notice that this program very nicely lists each of these JPEG files here for us. And these are listed in ASCII order, not necessarily numerical order. So for example, it goes 1, 10, 100 because 1 is the first digit in each of those, and then eventually when you get to one that does not start with 1, then it'll get to 2 down here and so on. So then it goes 2, 20, 21. So the order is something to keep in mind there, but in any case that doesn't really matter. So if we expand this out, so this program is very user friendly here, so you can control a mouse wheel to zoom in and zoom out. And if you mouse over a certain, like I'm going to mouse over the top left corner of the image up here, and then mouse wheel in, it'll zoom in on that corner. And then of course, you know, similarly, if you want to zoom in on the bottom right corner, and then you can mouse wheel over that. You can mouse over that rather, and then mouse wheel and it'll zoom into there. So that makes zooming in and out to certain locations very easy. There, unfortunately, there is not like a left click and pan feature. That's maybe the only thing the program's missing, but it's very user friendly otherwise, so that's really not a problem. So if we zoom in on one of the traffic lights here and we draw a box like so, and then it will ask us how do we want to classify that. So we'd like our XML to come out like this here. So we are going to, I'm going to copy and paste this to make sure I don't make a typo while I'm making this here. So we're going to call that traffic light, and you're going to see we're going to end up with this XML in just a moment. So if we paste traffic light in there, make sure you don't have any spaces or anything and choose OK, or alternatively up here where it says use default label, you can paste that in there and then check that box. And then we scroll over and there's only one other traffic light in this image, so we simply choose create rec box again, draw another rec box around that, and then you can choose save. And the program is intelligent enough to figure out to save it in the same directory that you're already working in, and it will save the image as, or it'll save the XML file rather, as the same name as the image file, but of course it will save the extension as XML rather than .jpeg. So if we choose save there, and then we go to the next image, and I'll just do one more of these just as a quick example here. There's no sense in me going through all 127 of them. So if we go like this, and then we're going to do another rec box like this, and trying to get it lined up right there. And then there was a third one in this image, I believe. Yes, there was. There we go. So create rec box, and there we go. And then we're going to choose save once again, and then save, and then you could choose next and go on to the next one. Again, I'm not going to go through all of those because it'd be very time consuming, but if you open XML, so let's take a quick look at this. So it tells you the directory name and the image name. You don't have to update the path if you move this around, because for the rest of the process that's actually not used. And there's some other information here. The width and size of the image, and the depth is the number of channels, 3, but the especially critical information that we're interested in here is bounding box. And this gives us the xmin, ymin, xmax, and ymax of that box we just drew. And of course there's 2 of them because we drew 2 boxes. So then similarly, when we go to 10.xml where we drew 3 boxes, now of course there's 3 of these traffic light objects with the bounding box specified. So to save some time while I was making this video, obviously if you're doing this process again to detect totally your own custom object that you're going to train, you'll have to go through however many images you have, but the label image program really is pretty user friendly and makes it pretty quick to go through it. However, still, to save some time when I was doing this video, or if you'd like to just skip on to the next steps and not worry about setting up the XML files yourself at this point, I did download, let's see here, or upload I should say, the those same images with the associated XML files created also to my Google Drive and OneDrive. So then you can go ahead and download those. So let's see here. And of course I already did that ahead of time to save some time in recording this video. So if we go to downloads, that's what these here are: traffic lights with info, and then traffic lights with info. So these 2, I forget, one of these is the OneDrive and one is the Google Drive. I forget which is which, but again, it doesn't really matter. So we can delete this traffic lights directory from earlier, and then if we go into traffic lights with info, and then we can choose copy this, and we'll paste that into downloads, and that takes just a moment to extract. So there's our 127 images, and each one has its matching XML file. So at this point, that's actually most of the legwork. Now we pretty much run these 5 Python scripts successively, and it would be a good idea, if this is the first time through the process, I explain a lot of things in much more detail in the walkthrough document. But to save some time in this video, I think I'm going to just kind of run through the scripts, and I made the error messages when running the scripts absolutely as user-friendly as I possibly could. So if you forget a step, most likely there'll be an error message that should be pretty friendly as far as suggesting what to correct. So for example, if we open one XML to CSV.py, this is going to translate the XML information we just downloaded into some CSV files, which is necessary for the next step, which changes those CSV files into TF record files, which is TensorFlow's recommended storage method of data, which is necessary to then feed into the next step where we're going to train. So if we go ahead and run this here, one XML to CSV.py, of course it's going to give us an error message because we didn't create any of these images, or any of these directories rather, yet. So error, the training images directory does not seem to exist. Did you set up the training images? So we did not. So we're going to create, actually, why don't we just move this so we can do traffic lights with info. We can move that into the repository we've been working in, and at this point we don't need the downloads directory anymore, so we're going to rename traffic lights with info to training images. And once again, there's our 127 images, each with an associated XML file. So now if we run this, it's going to say error, we didn't separate out any test images, I believe. Test images directory does not seem to exist, so we're going to create a test images directory. So new and test images. So now we're going to go into training images, and we're going to just randomly pick out, so 7, let's pick out, say, 10 image and XML file pairs to test on later. And of course we don't want to train on those same images, so we're going to move those into test images first. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And taking care here to make sure that we choose the matching image and XML pair. For example, don't accidentally choose 116 XML and 117 JPEG. So I'm kind of making sure I do that correctly as I go here. So we're going to move those into test images. And sure enough, there's our 10 pairs of images and associated XML files moved into test, and we now have 234 divided by 2 remaining images in training images, which is a sufficient number to train on. Really, you want more than 100 images to train on. So at this point, we can go ahead and run xml to csv.py, and we should not get any errors. So converted, training XML to CSV, conversion successful, and then test XML to CSV conversion successful. So what that script did for us is it set up this training data directory and these two CSV files. So let's just take a quick look at the format here. So each line in this CSV file corresponds to not one image file, but one box. So for example, you recall that image 10.jpg, there were 3 boxes that we drew. So sure enough, there's 3 lines in here. And then these last 4 numbers, of course, are those box coordinates. So that worked successfully. So now we can run generate TF records. And we need to give PyCharm just a moment to load up here. And then the next step when we're done with this is going to be to run, well, let's go ahead and run this first. So it'll take just a moment here for PyCharm to do its parsing pre-checks here, and then we can go ahead and run this. And just another moment yet, 2 processes running. Okay, let's go ahead and generate TF records, and successfully created. So we're all set there. So now if we go back to training data again, now we have train.tf record and eval.tf record, so that was successful. And now we're going to open up train. And this script takes on my computer with a little bit more than 100 images to train on. It takes quite some time. It takes about 4.5 hours because I don't have a GPU in this computer. Also, this is not the latest and greatest computer out there, so if you have a newer computer or if you have a GPU, this may take substantially less time for you. If you have an equivalent computer, it'll probably take about as long. So this is something you may want to start just before you go to bed kind of thing, and then leave your computer running overnight. But in any case, we still have to download a model yet, so we'll go ahead and run this, and it's going to tell us we have to download a model. I believe it will take just a moment for TensorFlow to load up, of course. That's what the delay is here. TensorFlow is, as you would guess, a rather large library, so while we're waiting for that, we'll bring up the downloads directory. So, okay, there we go. So, error, the model directory does not seem to exist. Did you download and extract the model from the TensorFlow models repository detection zoo? So we did not, so we're going to open that now. I don't know why that opened twice, but in any case, TensorFlow detection model zoo. So there are a number of models that we can choose from here. I'll kind of explain these quickly. Again, there's substantially more detail in the walkthrough document where I elaborate on this a little bit, but to make a long story short, SSD MobileNet v1 is, as the name implies, it's intended for mobile processors. So if you're running something that's streaming video on, say, from a webcam where speed is really essential, you'll probably want to go with MobileNet. Whereas these others, and over here you see speed and accuracy, this Cocoa M API 1 is the measure of accuracy. The higher the number, the better, generally speaking. So some of these other models here are trained for more particular purposes, depending on what type of object you're detecting out of what type of scene. Some of these might be better. However, generally speaking, for still images where speed is still important to a degree but not as essential as for streaming video, probably SSD Inception v2 in most cases is going to be the all-around best choice, so that's what we're going to go with today. So I already downloaded, so you're going to go ahead and click on this and then download that. And I already did download that to save some time in recording this video. So if we go to downloads, and then this here, SSD Inception v2 Cocoa 2017-1117 tar.gz, and then we copy that over here. And that'll take just a moment to copy. We don't need the downloads directory anymore. So you'll want to download 7-zip. So 7-zip, and let's see if you have a 64-bit computer, which you probably do. You're going to want to go ahead and download this right here, install it if you have not already. And once that's done, then you'll have this nice context menu, 7-zip, and then extract here. And that's going to, on the first extraction, is going to extract the tar.gz into just a .tar. And then we're going to go 7-zip and extract here again. And that extracts to this directory here, SSD Inception v2 Cocoa 2017-1117. Go ahead and verify that there's some contents there, which there are. And if we start this one more time, we're actually going to get a temporary error here, and I'll explain that in a moment. And the reason for this error is because you do have to bear in mind, as I mentioned earlier in the video, the TensorFlow models repository is still kind of under development. and I actually have a pull request out to the TensorFlow models repository, as well as an issue that I filed to fix this concern. Basically, there's a parameter. Okay, here we are. So TensorFlow models research object detection data decoders TF example decoder dot line TF example decoder dot py line 110. And I did not put this in the walkthrough document because I hope this is going to be fixed very shortly. But for the moment, this function call here image does not seem to actually have this DCT method. So the fix for that's very easy. You simply delete the comma on the previous line and then delete this DCT method equals DCT method. So you're going to delete just what's highlighted there. I'm going to press backspace, and then PyCharm is going to remind me that this file does not belong to this project. Yes, we know that, and we want to edit this file anyway. Choose OK, and now at this point, when we go ahead and train, the training process should begin successfully. And again, this takes about 4.5 hours on my computer. On yours, it may take less if you have a newer computer or a GPU. But at this point, I'm going to stop the recording because this takes pretty much all the memory of the computer to run, and I don't want my screen recording to crash and lose the screen recording that I've done so far. So just once again, I'm going to give this just a second here to make sure this has started okay, and then I'm going to stop the recording. Okay, it looks like it's starting well, so I'm going to go ahead and stop the recording now. Okay, so back at it here. Our training process just finished. So this is more or less how things should look when training is done, and I'll go ahead and sweep back up to the very top so you can see this is a quick view of how things should have looked like as we got into the training, and then you can see here the steps are counted up incrementally, step 1, step 2, step 3, etc. On my computer, it takes roughly 30 seconds per step. Again, if you have a newer computer that's better than this, or a GPU especially, that may be substantially less. And I included a screenshot of how the training process should start out, and then also what it should look like at the end in the walkthrough document, so you can reference that if you have any concerns or if you're experiencing any errors for comparison. But in any case, that completed successfully for us, so we're going to go ahead and exit out of PyCharm. And we're just about done here. Just two quick final scripts to run. So we're going to run export inference graph.py, and that's going to create a graph, directory rather, in our working repository here that I believe is called inference graph. We got to give PyCharm just a second to load up. And then after that, we can go ahead and run test. And these scripts don't take very long. I think export inference graph only takes perhaps a minute or so to run, if even that. And we just got to give PyCharm here another minute to load up. So we'll take a quick look at the walkthrough document. Okay, there we are. It's almost there while we're waiting here. Okay, it slides over and we're almost ready to go here. So again, this follows a pretty similar format to the other of these 5 scripts in a row here we're running. So there's a function here that checks if the necessary paths and files exist, but I think they're all pretty much made since we've completed the training process, so we can just go ahead and fire it up here. So export inference graph, and we need to give that just a minute to load. Again, this import TensorFlow as TF line always takes a moment because of course TensorFlow is a pretty large library to load. And then we should see the inference graph directory appear in here eventually, I believe. Just got to give it another minute. So we'll shoot to the bottom of the walkthrough document here. So for the next step, we're going to run test.py, and then we're going to find, this is one example result. Let's see how this is doing. Still got to give it another minute here. And what we're going to find is that we're going to get about, I found about 60% roughly accuracy with finding these traffic lights. And the reason for that is because we only trained on a little bit more than 100 images. If you wanted really production grade accuracy, well, more on that in a moment here. This is running here. Okay, so starting script, calling train eval pipeline config, etc., converted 410 variables to constant ops, and done. So we're all set there. So we can go ahead and open up test, and while we're waiting for that to open, we'll take a quick look at the inference graph directory. So you can see that process just created these files here for us, so that worked out well. And now test should be almost open here. And we'll give this just another moment to load. And so, as I was saying earlier, we're going to find about 60% accuracy with finding these traffic lights. And depending on which random images you take out and separate to test on later versus which ones you train on, that will be a little bit better or worse. And the reason that that isn't extremely high, I mean, this would be really, really high if not for the fact that we didn't use enough training images, and also we set the number of steps down. You may recall in this SSD Inception v2 config file, the default for this, and you can reference the original file from Google here by following this link if you're so inclined, so then you can see what settings we've changed. 4.5 hours is pretty long to wait for training, so here's the original. So let's see, I believe they have num steps set to 200,000. That would give probably a lot better accuracy, but to keep the training time down to something reasonable, I set num steps down to, I believe it was 500 here. And then the other thing would be just using way more images instead of just a little bit more than 100. If you used, say, 10,000 images of traffic light scenes and then increase the number of steps to perhaps 5,000, you'd probably get upper 90% accuracy. But in any case, we'll go ahead and run it with what we have so far. And hopefully we'll see that we get at least 60 or so percent accuracy depending on which images we separated out. So that's pretty good, 2 for 2 on that one. And that one, we wouldn't really count the backwards facing traffic lights, so, and these ones in the distance are kind of far off, but these two here ideally should have been detected and only one of the two was, so we'd call that maybe 50%. In this image, none of them were, and it's something to do with the sky in the background or the lighting. It's hard to explain. In this one of two was detected, so obviously we missed this one on the right here, but the one in the center is a good detect. And then in this image we got 2 out of 3, so that's pretty good. And in this image we got both of them. That's especially good, being that this one that we detected up here is one of these kind of odd sideways slanted ones. And then in this image, out of, it looks like there's really 5 that we should have gotten. We got 3 of them, so again that's right about the 60% range. And then here we got 1 out of 2. So and then this one we got 2 out of 2, so that's pretty good. And that one we missed them all. So it's kind of a hit or miss thing with this few training images. If you train on way more images, it would be super accurate. So that completes this tutorial and these first 3 tutorials. So we did a installation on TensorFlow and walked through the first few programs in the first one. Then we did classification and then object detection in this tutorial. So some ideas I have in mind for the next tutorial is I'd like to redo either the second or third tutorial in C++. I'd like to redo either the second or third tutorial in .NET. There are some very good NuGet packages that are .NET wrappers for TensorFlow. And another thing I'd like to do is get a GPU and go through the configuration process and then do a walkthrough on that as well. So if you have interest in any of those options, please comment in the comment section below. Please rate, comment, and subscribe. And I'm not sure when I'll have the next video out, but eventually, and I'll see everybody in the next one.